Okay, so we have already rest for 2 days. So today we want to continue about the alternating current through a capacitor. So this is the AC currents that learning the AC current through a pure capacitor, only capacitor in a circuit. So we know that the charge stored in a capacitor, we denote it as Q. So this is the charge. On the capacitor. So C will be denoted as the capacitance of the capacitors. While V, so this V we can denote as a source voltage and also the voltage across capacitor, because the V provided by the source will be equal to the V across the capacitor. So we know that alternating current is a current that always changes in direction. So in other words, we have this type of current. So due to the current is alternate or being increase and decrease periodically, so means that the capacitor is being discharging and charging. So it will be discharged and discharged according to the current flow through it. So we know that for the equation of the charge that stored inside your C will be equal to Q equal to CV. So this is the equation that you learned from the previous chapter about the capacitor. So now let's just derive the equation for the phasor of voltage phasor and the current phasor. So now we derive the current phasor from V equal to V naught sine omega t. So if we start from V equal to V naught sine omega t, so we have this equation Q equal to CV and this equation V equal to V naught sine omega t. So we know that Q is actually the definition of the rate of change of your So because of the current inside the AC circuit is changes periodically, means it will changes according to the time with respect to time. So we have dq per dt because it always changes according to time. And this one, V, is also changes according to time, so we have dV dt. Okay? Why? Because of the alternating current. Okay. So now dq dt is actually the rate of change of flowing charge, so which is your current. Okay? dq dt is your current. So you know that dq dt is actually rate of change of charge, which is your current, and dv dt. Okay, now because V can be denoted as V naught sine omega t, so we differentiate V naught sine omega t with respect to t. So when you differentiate this one, so you will get cos omega t times omega. Okay? So I write it again because I have already CV naught, because you differentiate this sines omega t, so you get omega cos omega t. Okay, so you get this equation. So comparing with the equation of your phasor diagram, so you have this I equal to I naught cos omega t. So if you compare this, your I naught is actually equal to CV naught omega. Okay, in other words, your V naught per I naught is equal to 1 per C omega. Okay, can you understand this one? So now, what is actually this? So in the previous lessons, which is your alternating current through an inductor, we have V naught equal to I naught is actually your reactance through the inductor. So this is the reactance through your inductor, which is equal to V naught I naught. While in your alternating current through a capacitor, so your V naught over I naught is known as reactance through a pure capacitors, which denote as XC, and equal to V naught I naught, which you can be written as V_r.m.s divided by r.m.s, which your V_r.m.s is still V naught per square root 2. So this is your reactance of pure capacitor. So this reactance pure capacitance is actually your oppositions to the current flow by a capacitor. Means the measurable of the how well the capacitor can resist to the current flow. So this reactance of pure capacitance can be denoted as V naught over I naught, and it can also be equal to 1 per C omega. So remember, C is your capacitance of your capacitor and omega is your angular frequency. So I just write here if you confuse. So C is your capacitance and omega is your angular frequency, or some will be written as angular velocity. Is it okay? So here, from here we know that omega is 2 pi f. So in other words, your SC can be written as 1 per 2 pi f C. Okay, here you have XC is inversely proportional to 1 per F. Okay, which is, you have this type of graph, because XC is inversely proportional to F, so you get this type of graph. So when your F increase, your XC will be decreased. In other words, when your frequency of the alternating current increases, your reactance through the pure capacitor will be decreases. Well, if you compare this one with I naught, so if the relationship between your I naught, so if you look at this one, okay, or you say that V naught equal to I naught is equal to 1 per 2 pi FC. So your I naught is actually directly proportional to your F. So in other words, for I versus F graph will be a straight line graph because of the directly proportional to the F. I is directly proportional to F. Okay. So this is almost the same as your previous alternating current through a capacitor, but there is a small difference. Just now I have already forget to mention this. Okay, if you derive your currents in the from the V naught, V equal to V naught sine omega t, you will get your I is equal to I naught cos omega t. So from here we know that the phasor diagram for V is in this direction, but your I naught is in this direction. Your I is in this direction. So in other words here, from here. So we know that I0 is actually leading your current of your capacitor is actually leading your phasor V by 90 degree or pi per 2 radian. Okay, so remember, for your inductor, for your alternating current through your inductor, V will be leading I 90 degree. But for alternating current through a capacitor, it will be the other way around, which is your I leading V by 90 degree. So I is before your V. Remember, it's rotate in anti-clockwise direction. So these are a few things that you have to remember for your alternating current through a capacitor. Yeah? So I want you to do these derivations. Means you have to pass up through your WhatsApp. I know you haven't passed up anything to me. You didn't show me anything about the previous lesson derivation. So please do it. Okay, I don't want to scold you because you have already Form 6. Okay, so I want you to do the derivation of an expression for the voltage, the circuit from I equal to I0 sine omega t. Okay, so you do this one because just now I've shown you this one. So I have shown you this one. Okay, so this is I derived the current in the circuit from V equal to V0 sine omega t. But now you try to derive voltage from I equal to I0 sine omega t. Okay, this is a word that you have to complete. Okay, now after you have learned that phasor I is actually leading your phasor V by 90 degree in your AC through capacitor. So now we want to derive the instantaneous power. And also your maximum power. Okay? So your instantaneous power is still the same, P equal to VI, which your V will be T0S. So in the previous one, so you have your V is equal to V0 sine omega t and I is equal to I0 cos omega t. Okay, so V is equal to V0 sine omega t and I is equal to I0 cos omega t. So when these two combine, we have V0, I0 sine omega t cos omega t. Remember this one will become sine 2 omega t per 2, which is from your trigonometry law of your trigo. So in other words, V0 I0 per 2 sine 2 omega t is your instantaneous power. Okay, then for maximum power. So you remember maximum power is when your sine 2 omega t is equal to 1. So for your sine 2 omega t is equal to 1, then your maximum power will be equal to V0 I0 per 2. Eh? Okay, now, so how do you plot or sketch your graph? So if you look at your textbook, because your textbook already show you how to draw, so I just discuss it from here. So if you have your V is equal to sine graph, so you have look at this one, V is your sine graph. So which is your V is equal to V naught sine omega t, and you have your I is equal to I naught cos omega t, and your P will be equal to V naught I naught 2 sine 2 omega t. I believe that you know how to sketch this one, but I just want to remind you again. So for your V, you get sine graph for this one. So you have your sine graph here. Well, for current, it's a cos graph, so you have cos graph for your dot here. Now power. Power is a sine graph, but because this show you have two complete oscillations in you have two complete oscillations compared to your first one, which is when your V oscillate one complete oscillations, your P will have two complete oscillations. Okay, I repeat, because this one compared with your V, you have 2 omega t, means that it's actually have twice angular velocity than this one. So when you have this one, means it will oscillate faster than your voltage, so which is twice your oscillations of your voltage. So when V complete one oscillations, your P will complete 2 oscillations. So when your V is 1 oscillation, your P has 2 oscillations. So this is how you plot your graph. So what's your average power of the capacitor? So if you calculate average power, so this is your mean power, and V naught I naught 2 is constant, so you no need to find your mean power, a mean value for this one, but for sine 2 omega t. So in your previous lessons, you know that mean of sine 2 omega t is actually 0, which you can get from your integrations. I don't want to show you again. So in other words, for your mean power, this one is your mean power. Okay, if you cannot get it, mean power means your average power. So your mean power is equal to 0, which means that there is no heat dissipated through the capacitor. Okay, so there is no heat dissipated in pure capacitors. So why? Because your heat that being absorbed by your capacitor will be released onto the circuit. So which is from here. The explanation is from here. So the positive power means the positive cycle here is actually absorb the power. Your negative is releasing the power, and there's no net force, or there's no net power, means the energy absorbed by the capacitor is during one complete cycle. Okay, so this one, how do you calculate your energy stored in capacitor? So you know that for an energy stored in a capacitor, which is equal to U equal to, so I want to show you energy stored in a capacitor. So for your energy stored in capacitor is equal to half CV square. Okay, U is equal to half CV square. So if V is equal to V naught sine omega t, so you will have U equal to half C V naught square sine square omega t. So this is your energy stored in your capacitor. So it will be different, so it will be always changing according to the time. So what's your maximum U? So your maximum U is when this one equal to 1. So in other words, your maximum U will be equal to CV naught square. So if you look at this, you know that your maximum U, maximum energy stored in your capacitor, happens to be when there is a maximum voltage. In other words, here, because this is a voltage, so here is your V. So the maximum energy stored in capacitor is when your V is the maximum, then your U stored in your capacitor will be maximum. So maximum at here, this point. Okay, don't confuse with this one, because this one is the instantaneous power, means it doesn't do any job here, so the energy is being stored here. So in other words, is here is the storing the power, sorry, the energy stored is maximum at this point. Okay, is at this point. Yeah. Okay, so for that's it for today's lessons. I mean, for this alternating current through a capacitor. So I want you to do a short notes about the alternating current through resistor, AC through resistor, AC through inductor, and AC through capacitor. So later I will give you a table to complete, so please look at the file that I will attach through your WhatsApp. So do a summarize for your AC through resistor, inductor, and capacitor, because these three will actually help you in your coming lessons, which is your RC, RL, and RCL circuit. Okay, so it means that I have already completed this subtopic, so you have to complete your exercise at 18.5. Okay, for question 1, you just ignore it because the question is incomplete. There's a lack of information, so for the other one, you can do it until question 9. So tomorrow I will continue for your RL circuits, and then RC circuits, and then RCL circuit. So I think you have another 3 lessons to complete this set. Okay, thank you for today. So remember, please do your exercise. Please do whatever I have told you to do. Don't lazy. Okay, take care.